Welcome to this short video on landslides. Understanding why landslides happen and where they happen is important for a lot of reasons, and one of these reasons is apparent right here in this picture. Now what we'll see is that steep slopes and rainfall are often important ingredients for triggering landslides. So let's take a look at why that is. Some of you may recognize this setup. This is your classic sliding block on a plane. So you might have seen something like this if you took physics in high school or like an introductory class to physics in college. And the idea is that it's just a simple block. In this case, you could think of it as a brick on a piece of wood, on a plank of wood that's inclined at an angle. And now it turns out that landslides are very similar to blocks on inclined planes, and the physics are very similar. So let's take a look at the physics of a sliding block on a plane. So the first thing we need to figure out is gravity. And so gravity, of course, goes straight down. And so the gravitational force is being exerted on this block. Now gravity can be broken up into two components. And so the way you want to think about this is in terms of arrows. And technically, we would call these vectors, but as you'll see, we'll just refer to them as arrows. So the gravity vector or the gravity arrow can be broken up into two smaller arrows. So one arrow is perpendicular to the sliding plane, to the inclined plane. And we call that the normal stress. And then there's another arrow that is perpendicular to the normal stress or parallel to the sliding plane. So in this case, the black line. And we call that the shear stress. And so the normal stress and the shear stress, these are two components of gravity, and they form a right triangle. So you can see that the normal stress and the shear stress are perpendicular to each other, and they form, with the gravity vector, the gravity arrow, a right triangle. Now the normal stress is important because it's what keeps this block essentially pinned to the slope. So it's the normal stress that's forcing the block to be in contact with the inclined plane. The shear stress, however, is doing the opposite. And what we can do is we can take the shear stress arrow and so what we can do with the shear stress arrow is actually bring it up here, and what this represents is that the shear stress is actually trying to pull this block down the plane. Okay, so gravity here has two components. Gravity is doing two things. In the normal stress direction, it's pinning the block to the plane. And in the shear stress direction, it's trying to pull the block down the plane. And so in this case, because the shear stress arrow is smaller than the normal stress arrow, this block isn't moving. So in this case, because the normal stress arrow is the larger of the two, it's winning out and it's keeping the block fixed to the plane. Now let's look at another example on a significantly steeper slope. So first we draw our gravity arrow. The gravity arrow is always straight down. And then we have our normal stress arrow. The normal stress arrow is always perpendicular to that black line, to that plane, the inclined plane. And then here's our shear stress arrow. And the shear stress arrow is always perpendicular to the normal stress. So again, we have our right triangle like that. And if we compare these two stresses, if we compare the length of the arrows, we see that on the steeper slope now, the shear stress arrow is longer than the normal stress arrow. And so what this means then is that within these two components of gravity, the shear stress is going to win out, and the block is going to slide down. And in the case of a landslide, this means that you would get a failure. So in this case, it means that under these conditions, the landslide would fail. So you see then how the slope of the surface is really important when it comes to landslides. So steep slopes are more prone to landslides than shallow slopes. Now let's look at the effect of rainfall. So this is essentially the same picture. In this case, I've not drawn the gravity component. I've just drawn the normal stress in green, and then we have the shear stress in red. And to make things look a little more realistic in terms of a landslide, we have a layer of soil on top of bedrock. And so now let's rain on our landscape. So these are rain clouds. And here's the rain coming down. Now, as you might expect, rain will percolate through the soil like this. But when that water hits the bedrock, it's going to start pooling up on the bedrock surface. And the reason for that is that bedrock has a much more difficult time allowing water to infiltrate than soil. So the water infiltrates easily into the soil, but then it hits the bedrock and it starts to collect there. And so you get what's called a perched aquifer. And so as the rainstorm continues, that water continues to collect on the bedrock surface. So this is all saturated soil, which means that every pore, all the pores in the soil are just filled with water. Like that. Now, this has an important consequence when it comes to the normal stress. So remember, the normal stress is the green arrow right here. And this is because water has a buoyancy effect. So, for example, if you were to try to pick up a 50-pound rock on land, you might think that it's kind of heavy. But if you put that rock in water, say at the bottom of a pool or at the bottom of a river, it's much easier to pick up. And the reason for that has to do with the fact that water essentially makes things feel lighter because the water itself is bearing some of that weight. And so the same thing happens with water in soil. As water starts accumulating along the bedrock and it starts filling up the soil with water, the normal stress actually gets less and less. And so as that normal stress decreases, we're going to decrease this green arrow. And notice that at some point, as the water keeps accumulating and collecting in the soil, that green arrow is less than the red arrow, so its length is less. And as a result, you're going to get a failure. Okay, so the idea is the same as we saw earlier, where we're comparing the lengths of the arrow, and because all the water here in the soil decreases the normal stress, the green arrow gets smaller and smaller and smaller until it's finally less than the red arrow, which represents the shear stress, and that leads to failure, and that leads to situations like this. Okay, I hope that was helpful. Thank you for your attention.